We don't often think about how lucky we are to have fresh water wherever and whenever we are. But for over 2 billion people worldwide, access to safe drinking water is not guaranteed. Millions of water wells fail each year due to poor placement, contamination, or declining groundwater. And the problem isn't just physical, it's informational. There's already massive satellite hydrology and terrain data available, but it's fragmented, technical, and inaccessible to the communities and organizations that need it most. And so we asked a simple question: what if anyone could see where a well should actually be built before drilling? And so we built Flow. It's a geospatial AI platform that maps where water wells should be built in order to last. It combines satellite imagery, hydrology data, terrain models, and contamination risk layers in order to provide a data-driven view of optimal well locations.
Yeah, so here's how it works. The user starts by logging in with our authentication system run through Auth0, as you can see by Mr. Yemen in the top right. And this gives context as to the map location and the actual geospatial data relevant to their country, and it prevents, users from other countries from accessing classified data. It also allows more contextual responses. So the first step is the pipeline in the planning stage. When the user inputs a prompt like find the optimal places to place wells in Yemen. So when the user types, we immediately create a job and return a job ID. So this keeps the interface fast because geospatial analysis can take a few minutes. So instead of freezing the app, the work happens in the background. And the first step in all of this pipeline is the planning stage, where we use Gemini to convert this natural language into a structured JSON prompt. For example, it determines how many sites to return, how far apart they should be, and what we should consider when prioritizing water access, as well as roads and nearby settlements. So Gemini only produces these settings, not the actual locations. And so when we click run, it's already done. And next, the geospatial engine takes over. It samples thousands of candidate points inside the selected region and actually computes features like precipitation, distant surface water, slope, flow accumulation, all of this context, and uses all of this to filter out bad terrain and score the remaining points to produce the top X amount of points and show this on the map. As you can see by these rain droplets, which signal where you should actually be placing wells. And so from that, we select the top locations. And then Gemini is used a second time, but to not only to return the expected results, but also to actually explain them. So it turns the computed numbers into short, human-readable reasons for each site, so you know that these water droplets are actually evidence-based and we're not just pulling things out of thin air. And to keep the UX fast, we actually run this in two passes. First, the user sees an initial set of results quickly, and a refined version appears later. So really the first appearance of the water droplets is just UI. So overall, Gemini handles the language and explanations, while the geospatial engine in the back makes the actual decisions, making sure that the system is fast, user-friendly, reliable, and explainable.